Good evening, and I welcome you, students. Last time we have discussed the characteristics of the sound waves. What are the important characteristics of the sound wave, students? Before we begin the session, what are the important characteristics of the sound wave? What we discussed?
Wavelength, amplitude, frequency, and time period.
Wavelength, amplitude, frequency, and time period. We discussed all this, and we also derived their formulas. And amplitude, frequency, time period. What are the SI units of wavelength, students?
Meter.
SI unit, important. Sometimes they may ask you. Amplitude is a distance. Frequency?
Meter per second.
Frequency? Cycles per second, what they are? Meter per second, where is it meter per second? What unit was given?
Hertz.
Did we define hertz? Per second. Time period also what are the units of time period? Time taken for 1
seconds.
So time period is 1 by mu. 1 by S minus is S. The units are important when questions and numericals are given, but we have to use SI units, and if they are not, we may convert them one into another. We discussed certain other factors also last time. What do you mean by pitch, students? What is the pitch?
When frequency is more, of the wave is more.
So the pitch of a sound is decided by the frequency. Frequency increases, the pitch will increase or decrease?
Increase.
Okay. The frequency increases, then pitch of the sound increases. For the student, a very important question was asked in the paper to the students. What is that? Question is on the screen. Distinguish between loudness and intensity of sound, student. Are they two same or different?
Different.
What is the difference? You have 1 to 2 minutes to answer the question. Important question. We are taking it up. What do you mean by intensity, student? If you write the definition, that is enough, because you are really carrying 1 mark. What is the definition of the intensity?
Sir, it is the amount of sound energy passing each second through unit area.
Amount of sound energy. Okay? Amount of sound energy passing out unit area per second. Per second. And what is the loudness, student? What do you mean by loudness?
When amplitude is very more.
Loudness is a measure of response of the ear to the sound intensity. Response of the ear to the sound intensity. The two sound may have the two sound waves reaching the ear may have the same intensity, but ear may be responding them differently. So loudness is a measure of response of the ear to the sound intensity, student. Therefore, the loudness of the sound or softness of the sound is dependent on its amplitude. Okay? It is dependent on
amplitude.
Dependent on amplitude. And sometimes certain questions will be given. When the question carries 1 mark, don't write too many points. Even writing the definition itself answers the question. Important point. They will give you certain graphs and ask you what is different and what is same, as you have seen in the previous video lectures. And students can see the previous video lectures anytime, if they have a difficulty or problem. What is the quality? What do you mean by quality or timbre of a sound?
Sir, it helps in distinguishing one sound from another sound.
So it enables to distinguish sound produced by two different instruments, two different persons, although their pitch and loudness are exactly the same. What is same in this? Pitch and loudness is same. What do you mean by pitch is same? Means frequency is same?
Yes, sir.
Frequency is same. Loudness is same means what?
Amplitude is same.
Amplitude is same. But the quality or timbre is different. Quality or timbre is different. What is a tone, student?
Sound having single frequency.
When a sound has a single frequency sound. Single frequency sound is called a tone. Is called a tone. These are certain things which we have studied last time. It is a recap just to know what we have learned. What type of questions? Direct questions are even given in definition, students. What is a note, student?
Sir, sound which is produced due to mixture of several frequencies.
Mixture of several frequencies are there. That is called a note, student. What do you mean by pleasant sound?
Sir, which is very nice to hear.
We say rich quality sound. Usually music, we have referred that music is a pleasant sound. Music is a rich quality sound, And when we say, student, unpleasant sound, what is unpleasant sound, students?
Noise.
Noise. All right, that answers most of the questions which we have been talking. Numericals will be solved from this, and definitions can be directly asked. They are usually asked in the chapter of sound, and we understood pitch and frequency. Pitch is determined by frequency, and loudness is determined by amplitude of the wave. Sound is a wave, and anytime there is a vibration, the sound is produced. Sounds are produced by the vibrations, Okay. Let us come to another important topic. Now the question before us is speed of sound in different media. The first question naturally will be there. Just as there is a speed of air, a speed of light you have. Do you know what is the velocity of light?
Yes,
Is the
sir.
velocity of light same in all the media?
Yes, sir.
Same everywhere. Velocity is same in all the media. Who said that? Velocity, light travels same in air, in water, and in different mediums, in solids, liquids, and gases. In vacuum, the speed of the light has been given. How much?
3 into 10 power 8 meter per second.
That is the speed of light in vacuum. In medium, what will happen? When the light will face a lot of particles in its path, will the velocity be same? Answer is no. Here we are talking of speed of sound in different media. So what will happen to the sound if medium is changed? What do you think? Sound will travel with the same speed?
No, sir.
So sound travels with a different speed in different media like solids, liquids, and gas. What do you expect? Sound will be traveling faster in which medium? Solid, liquid, or gas?
Solid.
Why? What reason could be given?
Because, sir, particles are very closely packed, so it will help in propagating the sound.
You have seen that how the sound propagates through the vibration of the particles. The particles vibrate the neighboring particles, come back to their original position, and then this particle goes, vibrations are transmitted in the series of compressions and rarefactions. You have seen it. So if particles are more closer, then naturally we will expect that yes, the sound will be traveling faster. So sound will travel. We will see the speeds of the sound in different media like solid, liquid. This is because sound travels in a medium due to transfer of energy from one particle to another particle of the medium. So sound is traveling by the transfer of energy. Very important one. How the sound travels? Transfer of energy. This is how the sound is traveling from one particle to another particle. Therefore, sound will travel with different speeds in different media. Questions have been asked, student. Simple question. Why does sound travels with a different speed in different media? What is the answer? Transfer of energy from one particle to another. So this is the reason we have given. Question was, why does sound travel with different speed in different media? This is the answer. Note down. Question number 1. Question number 2. How does speed of sound differ in different media? Question number 3. Why does the speed of sound change in different media? Question number 4. What is the speed of sound in different media? These are the questions which we are going to answer. Question. Always there is a question and try to answer. That is our point. Okay. Let me proceed further. What we will find, student? The speed of sound increases as you move from gas to liquid to solid. Important. The speed of sound will be more in solids, liquids, and gases. We have already answered the question. As you will see, this is the speed of the sound increases from left to right. The reason, which we asked a question, reason. Since the particles of solid are close to each other, so transfer of energy from one particle to another takes place in less time, faster time. In solids, particles are closely packed. So the transfer of energy will take shorter period of time from one particle to another. Hence, the speed of sound is large in solids. And in different solids, again, the speed will differ. Am I right?
Yes.
Number 1 point. Number 2, speed of sound in liquid is less than in solid since particles are away from each other as compared to solids. Is that correct?
Yes.
Number 3, speed of sound in gases is least. So this is our number 1, number 2, number 3 student. Less as the particles are far always as compared to solids and liquids. So the separation of particles is much larger in gases, and in liquid it is more than in solids. So the transfer of energy will be faster in solids than in liquids, and then the transfer of energy in liquids will be faster than gases. Therefore, this is the order of the speed of sound from left to right. Clear?
Yes.
Questions can be asked to you, students. Okay. Another question was asked, student. Did you see lightning? Have you seen lightning, students?
Yes.
Lightning. When lightning takes place, what do you see, students? Lightning first or sound first? There is a lightning and there is a sound, thunder sound. Which you see the first?
Lightning.
Lightning is observed first, student. So you see the lightning several seconds before the thunder. Why? Question. What is your answer?
Because the speed of light is more than speed of sound.
So the light is traveling faster than sound, so it will be seen first. The speed of light is much faster than the speed of sound. Very important question, students. Light is traveling at a very high speed, 3 into 10 power 8 meter per second in vacuum. I will assume that also to be in air because air has particles which are separated by large distances. So that is 3 into 10 power 8 meter per second in vacuum, which is assumed to be same in air also, almost. Okay. Here you can see that light coming out, and then you will see after a few seconds some thunders. There are observations. When we make them, then we understand more. Since the speed will depend on the temperature also, so when we will record the speed of the sound, measure and compare, temperature should be mentioned. If I keep the temperature constant, student, supposing here measurements have been done, student, the speed of sound in different media at 25 degree. Okay? So these are speeds of sound which have been measured at 25 degrees Celsius. Temperature is important. So you are measuring at 25 degrees Celsius in different media. Among the solids, which has highest speed of sound in here? Aluminium.
Yes, sir.
Aluminium is 6420 meter per second. That is the speed of sound in aluminium. Aluminium is a metal, 6420 meter per second. Then nickel, steel, iron, brass, glass, flint glass. These are solids. In liquid, water, sea water. Why the sea water is having higher? Can you tell me? This sea water has a higher, you see that distilled water, higher speed of sound. Speed of sound in sea water. Sea contains a lot of salts, you know. 1531 meter per second. And that is a distilled water. Distilled water is considered as pure, doesn't contain impurities. That means it is 1498. Here there are a lot of particles in the sea. You know, very salts are dissolved in sea when salt is obtained from sea. So this is a comparison. Ethanol is a liquid solvent, methanol. And in gases, what will happen? The speed is decreasing. The speed of sound decreases, students. This is a hydrogen gas, helium gas, air. In air, at 25 degrees centigrade, how much? How much it is written? 346 meter per second. Oxygen, sulfur dioxide, these measurements have been done and there is a table already in NCERT book. So we already given you an idea that it is dependent on how closer the particles are. The closer the particles, faster the energy transfer. Closer the particles, faster the energy transfer, and greater the speed. So greater the speed of sound. That's all we are saying. Is it clear?
Yes, sir.
Important. There are questions asked on the speed of sound. It is important point. Note down. Try to understand everything. That is our point. Now the next question is, what are the factors on which speed of sound depends? Question, we put up a question here, students, to you. Question, what are the factors on which sound speed depends, student? Factors. The speed of sound depends on the following factor: density of the air. Since we are living in an atmosphere, our atmosphere is air. So we are saying density of the air, temperature, humidity in the air, as well as the wind. First factor, we are saying density of the medium. In general, density of the medium. Speed of sound is inversely proportional to density of the medium. Speed of sound is inversely proportional to density of the medium. Inversely or directly proportional?
Sir, it should be directly proportional.
Is it wrong? Okay? The density of the medium increases. What will happen? Okay? The speed will increase. Which has a more density, air, water, or iron?
Iron.
Iron. The speed of sound is directly proportional to density of the medium. Greater the density of the medium, faster the speed of the sound. Thus, that is the reason speed of sound in air is low, because air is easily compressible. Or what we say, the density of air is less density. So, next, nature of the medium or material. Speed of sound is different in different materials. Nature of the medium or material through which it travels. Speed of sound is different. Air, again, that is the same thing, but we say density of the medium or material. This is the same thing, density of the material. Air is more than water, is more than iron. Air is a gas, liquid, and then solids. Another important measurements, temperature and pressure of the medium. In high temperature, sound waves travel faster due to fact that molecular vibration happen more frequently at higher temperature. If the temperature increases, what will happen, students? Temperature increases. More energy of the particle is more. The result will be, the vibrations will be faster. Okay? There will be more vibrations, more energy is there. Okay? And faster vibrations. So wave travel faster. What will happen then? Velocity will increase. So velocity will increase at high temperature. At constant temperature, the sound does not depend on the pressure of the medium. It does not depend upon the pressure if temperature is constant. For example, air, the temperature increases, speed of sound increases. As the temperature increases, speed of sound increases. For example, for air at 0 degrees Celsius, the velocity is how much? 332.
Sir, your screen is not.
This screen is not visible. Now it will be visible. Now, what is happening? Screen is visible?
Yes, sir, now it is.
Okay. What is happening here, students? With increase in temperature, as you see, the velocity of the air is increasing. At 0 degrees Celsius, 322, and at 22 degrees Celsius, how much is the velocity of air?
344 meter per second.
344 meter per second. So with increase in temperature, temperature increases, velocity of sound also increases. Note down. Another is humidity of the air. Sometimes air is humid means what? Humid air has got
Water molecule.
moisture is there. Moisture means there are water vapors in the atmosphere. And speed of sound is less in dry air. Speed of sound is more in humid air. Speed of sound in humid air is more than speed of sound in dry air. What could be the reason? What will happen? The density of the medium increases. When density of the medium increases, what happens? Density of medium increases, then what happens? Velocity of sound increases. Is that right?
Yes, sir.
Okay. Try to correlate everything so that we understand what is happening. Note down. Questions would be framed to students. Slowly, like this. Top question of what we studied right now on the screen. You have 1 to 2 minutes to answer the question. In which of the three media, air, water or iron, does the sound travel faster at a particular temperature? Because it depends on the temperature. With increase in temperature, sound velocity increases. Vibrations become faster. What is the answer for this question, student?
The sound travels fastest in iron.
So the speed of sound is fastest in iron, student. The speed is more in iron than water, than air. That is the.
Yes, sir.
So the reason we have already given. What reason you will write in the paper?
Sir, because density of iron is larger than the density of air and water.
Chalo. Here the simple things are solid, liquid and gas. No problem. Okay. Another interesting thing is coming, student. What is a sonic beam? When a body moves with speed which is greater than speed of sound in air. We have given you what is the speed of sound in air.
Yes, sir. Yes, sir.
It is said to be traveling at supersonic speed. And when they do so, they produce a sharp sound called sonic boom. Sonic boom. You see what happens? You fire a bullet. jets, aircrafts, ठीक है, when they move with a speed faster than the speed of sound. Move with a speed faster than speed of sound. What will happen? They will produce a sharp and loud sound. They will produce what? They will produce sharp and loud sound. That is what we call sonic boom. This is a sonic boom. Supersonic speed is the speed of object that exceeds the speed of sound. For objects traveling in dry air of a temperature 20 degrees centigrade at sea level, this speed is approximately 343.2 meter per second. That is the speed, supersonic speed, which is more than the speed of sound in air. When a sound producing source moves the speed higher than that of sound, it produces shock waves in air. These shock waves will carry large amount of energy. The tremendous air pressure variation caused by the shock wave produces a loud burst called sonic boom. The sonic boom produces intolerable loud noise which cause pain in ear, shatter the glass panes of the building also. You know what can happen? If an aeroplane is flying very low, what will happen? The speed is high, then it will produce shock waves which have a lot of energy. So shock waves will produce loud bursts, and the result will be there will be pain in air, shatter the glass panes of the building. So let us see what we mean by sonic boom. When the speed of any object exceeds the speed of sound, it is said to be traveling at supersonic speed. That is greater than the speed of the sound. Bullets, jet aircrafts travel at supersonic speeds. Which travel at supersonic speeds? Jets. Okay? Bullets, aircrafts, and they're producing a source moves with, when the source producing moves with speed higher than that of sound, it producing shock waves. What will they produce? Shock waves. There is a large amount of energy. Shock waves have large amount of energy. And the air pressure variation associated with shock waves produces very sharp and loud sound. So there is a variation in air pressure. Due to this, there is a variation in air pressure. Okay? So pressure variation associated with shock waves. This will produce what will it will produce? Sharp and loud sound. Sharp and loud sound is produced. And this is called sonic beam. What do we call sonic beam? They have enough energy to shatter glass and even damage building. What they can do? The shock waves have enough energy to shatter glass and even damage buildings. All this is going to take place. Important because such a question can be asked to us in the paper. Note down. Coming to another important part of sound. What is the reflection of sound? You have no reflection of light takes place. Light falls on an object. What happens? The object reflects it back. A reflected light comes to our eyes. We are able to see the objects. What happens to the sound? If I throw a sound on some wall, what will happen? It should bounce back into the same medium. So, when a sound wave is incident on a solid or liquid surface, it bounces back into the same medium. This is known as reflection of sound. Like light, sound too undergoes reflection from any hard surface and obeys the same laws of reflection with the light. It's important. Sound is there, it will go hit an object, okay? And hard surface is there. It will, like light, it also undergoes reflection and even follows the laws of reflection. In the light chapter, we have studied the laws of light reflection. What were the two laws of light reflection we studied in the chapter of light?
There is no chapter of light that you taught.
Okay, that is in 10th class. Okay. In 10th, we are teaching the reflection of light. Okay. Now, let us see. Okay, don't worry. Then we will be studying that. Sound is reflected well from hard surfaces. Hard surfaces are like wall, metal sheet, hard wood, cliff. Sound waves are much longer than light waves. The wavelength of sound wave is more than the light wave, so they require a much larger area of reflection. Important point. Sound waves are longer than light waves. So they require much larger area of reflection and require much larger area of reflection. This is an important point. There is a difference between light and sound waves. Wavelengths are different. Sound waves are longer than the light waves. Anyway, here are the laws of reflection of light were obeyed during, and sound also obeys the laws. What are the laws of this reflection of sound? There are two laws we have given, just as a reflection of light. Incident, reflected sound wave and normal at the point all lie in the same plane. The angle of reflection of sound is always equal to angle of incidence of the sound, similar to the laws of reflection of light. Note down these two laws of reflection of sound, and we will perform an activity. We will perform an activity to prove that. Question is given. Okay. Perform an activity or experiment, okay, to show the reflection laws of reflection of sound. In the NCERT book, there is an activity student 12.5. What is that? First, this can be done in your science lab, in physics lab. Take two identical pipes. Consider two identical pipes.
Yes, sir.
As shown in figure 12.11. You can make the pipes using chart paper. The length of the pipe should be sufficiently long as shown. एक मिनट. Let us see what we are doing. ठीक है. The length of the pipe should be sufficient long as shown. They should be quite long pipes as you have seen. Pipe है ये. ठीक है. Arrange them on a table near a wall. ये wall है. This is a wall. ये एक table है. Table is attached to the wall. और ये pipes हैं उनकी. ठीक है. देख रहे हो 1 and 2. Arrange them. Keep a clock near the open end of one of the pipe. Number 1, number 2, number 3. यहाँ पर एक clock. You can see a clock is there near the one of the pipe. And near the open end of one of the pipes, and try to hear the sound of the clock through the other pipe. Other pipe से ये ear है आपका ear. Try to hear the sound, ठीक है, through the other pipe. अब you will have to adjust the position of this pipe to hear that sound. ठीक है, adjust the position. Fourth point, adjust the position of the pipe so that you can best hear the sound of the clock. Adjustment क्या करनी है? बेस्ट साउंड आपको मिले टू हियर बेस्ट साउंड. कहीं देन एट सम पॉइंट द साउंड विल बी फीबल. इफ आई चेंज द पोजीशन, इसकी पोजीशन आप चेंज कर सकते हैं. तो समटाइम्स यू विल नॉट गेट द बेस्ट साउंड. मींस बहुत फीबल सा साउंड मिलेगा. जहां पे बेस्ट मिलेगा वहां पर इसको देना. नाउ मेजर द एंगल्स ऑफ इंसिडेंस and reflection and see the relationship. आप ये एंगल मेजर करिए. ये देखिए this point, this is the normal. तो ये जो है ये एंगल ऑफ इंसिडेंस है और ये जो एंगल है रिफ्लेक्शन है. दो एंगल मिलेंगे, एंगल आई एंड एंगल आर. ठीक है. तो ये चार्ट पेपर था. चार्ट पेपर पे आपने ड्रा कर लिया. यू कैन ड्रा ऑन द चार्ट पेपर. मेजर द एंगल ऑफ इंसिडेंस. मेजर angle I and angle R and see the relationship. What is the relationship? क्या मिलेगा?
Sir, angle of incidence will be equal to angle of reflection.
The relationship you will get, student, angle I is equal to angle R. ठीक है. Lift the pipe on the right vertically to a small height and observe what happens. तो जब इसको vertically lift करोगे तो वो कह रहा है कि क्या होगा. What will happen if you will lift it vertically? This is an activity, student. ये activity है जो हमें perform करनी है. This is an activity which we have to perform. तो ये activity हमें perform करनी है, students. We have to perform this activity. और इसका रिजल्ट हमें we have to write the result of this. समझ में आया कि क्या किया हमने?
Yes, sir.
So students, what is our concept board? What we have done? Key takeaway. What is the key takeaway today? क्या क्या सीखा हमने? सबसे पहले we have learned that sound travels at different speeds in different medium. तो fastest कहाँ होती है sound?
Solids.
Then liquid, then gas. Then we said sound also depends on the temperature. If I will increase the temperature, what will happen to the sound?
Sound will increase.
Okay. With increase in temperature, sound waves increase. That was number 2. और थर्ड में हमने क्या शो किया स्टूडेंट कि व्हाट इज ए सोनिक बीम, क्या होती है? व्हाट इज अ सोनिक बूम?
Sir, when speed of an object exceeds the speed of sound.
Examples?
Jet airplanes, bullets.
What will happen if they fly? Then they can shatter the panes, glass panes, as well as some building can be damaged.
Yes, sir.
But they create shock waves. Shock waves. What are the laws of reflection of sound similar to laws of light?
Yes, sir.
Can we perform an activity to demonstrate it?
Yes, sir.
Okay. Sometimes they can ask you these activities. These experiments, 1 or 2 experiments are asked, which are given in the NCERT book as activities. All right, we stop here. We will continue in the next class further about the sounds and see what are the different applications of the reflection of sound and how we apply in everyday life. Okay, then we'll meet you next time.
Thank you, sir.
Okay.